This is LO4, Why Water is Important for Life. Before we begin, just a quick reminder. Remember that an atom is the smallest part of an element. It's the most basic piece of an element. And a chemical bond is an attraction between two or more atoms that makes them more stable because they're bonded together and balancing each other out. The first type of bond is called an ionic bond, and this is where you have two atoms and one is really strong compared to the other one. Atoms like to be stable if they can, so chlorine has 7 electrons in its outer shell, and this shell holds 8, so it really wants one more in order to make it stable. Sodium here has 1 electron hanging out in the shell that can hold 8, and so it'd be willing to give up its 1 electron so it can become a little more balanced. And so it does. Chlorine essentially steals the 1 electron from sodium, balancing both of them, making them stable, and then they become stuck together. That's an ionic bond. A covalent bond is when 2 or more atoms share electrons. So here we have carbon and 4 hydrogens. CH4 is methane. And carbon is sharing electrons with the hydrogens, so then carbon has 8 in its ring and the hydrogens have 2, because if we start getting back into what you did the Bohr models, the first ring has 2, the next ring has 8, they're just leaving out the inner ring of carbon. The third type of bond is called a hydrogen bond, and this is the one that's really important for water. It's a weak attraction between hydrogen and something else. In water, it's between hydrogen and oxygen. That's what you see going on here. And this is really important for creating certain properties in water, as we will see shortly. Now, the structure of water, it's made out of 2 hydrogens and 1 oxygen. And because of the way it's set up, it has a very special structure. It is a polar molecule. This means that when the hydrogen and oxygen are bonded to each other, the oxygen steals the electrons just a little bit more than the hydrogen. It's stronger. It can't strip them away totally, but it just holds on to them a little bit more. So oxygen is a little more negative, hydrogen is a little more positive, and really what I need you to know at this point in your science career is that this makes a difference in how the water bonds. This creates hydrogen bonding, which we just mentioned earlier. In water, hydrogen bonding occurs between the hydrogen of one molecule and the oxygen of another. The hydrogen bonding in water creates this lattice-like pattern that creates surface tension. So if you've ever belly flopped in a pool before, you're hitting the water and you're hitting this network of the molecules and slapping them, and that's why it hurts. This pattern also allows some bugs like water striders to be able to walk across the water. Now, what makes water so important for life? First, we have something called cohesion. Cohesion means water molecules like to stick to themselves, and that's what gives us that surface tension property. They like to bond together in a way that allows things to walk across and makes belly flops hurt. Water also likes to stick to other stuff. It adheres to other things. Adhesion. Water molecules like to cling to other things. This is how water goes up a plant. It's called capillary action, where it kind of creates a straw where the water likes to cling to the sides of the wall of the plant in the xylem, which is kind of like the plant's blood vessels. We'll get to that when we get to plants. But adhesion and cohesion allow the water to get sucked up to the top of the plant. The third thing that's important about water is that it has high heat capacity. It cools down and heats up really slow. Think about if you put a giant pot of water on the stove and tried to get it to boil. It takes a while for it to boil. It needs to absorb a lot of heat before it's actually ready to start boiling. And then, if you turn the water off, it's going to take a long time for it to cool down. An example of this, I'm from the Milwaukee area. I'm from West Allis, which is kind of around right here, where my mouse is right now. And the temperatures in the Milwaukee area are always different than they are in Fenimore, because during the winter, Lake Michigan is absorbing that cold. It's staying really cold. And then during the summer, it's still letting off that cold. There's a delay in the lake heating up. So summers tend to be a little bit cooler in Milwaukee than they are in Fenimore, and then as the summer goes on, Lake Michigan absorbs more and more heat, so then during the beginning of the winter it's still releasing that heat slowly, and the winter is just a little bit warmer in Milwaukee than it is in Fenimore. The next thing, water is a universal solvent, meaning almost everything dissolves in water. This is really important for transporting things around bodies. Most of our bodies are water-based, plasma, blood, and by being water-based we can dissolve things in it and transport stuff around bodies. This also works for plants and other organisms, not just humans, but this property of being able to dissolve almost everything is very, very crucial to life. Finally, ice density. Think about any other material. If you take aluminum and you make it a liquid, and then you have a solid piece of aluminum and you drop it, it's going to sink to the bottom of the aluminum. Water is the only substance that as a solid, as ice, the solid will float on the liquid. Nothing else does this. It's incredible. Everything else is the opposite. So think about why this is important for life. Why is it important that ice floats? You're going to answer that question for me later on, but just think about it. If ice sank instead, how would that impact life? So, now that we're done with this video, you need to complete the Water Stations lab, which takes place in the back of the room. The information is in the crate. And then you're going to do a worksheet that is called What If Water Didn't? And when you're done, you will hand that one in. As always, if you have any questions, see me, let me know. Otherwise, continue on, get your stations and your worksheet done, and then continue to LO5.